Question 11. Identify the discontinuity, if any. So in this multiple choice section on reciprocal functions, I have given two questions here, right? One is identify discontinuity in the graph of f of x equals to 2x minus 6 divided by 3 minus x. Now there could be two different types of discontinuities here. One is because of vertical asymptote and the other one is because of holes, right? So those are the two discontinuities which we are referring to. Now try to solve the rational function first and then look into the answer, right? So from here we can say we can take 2 common in the numerator, and if we do so we get x minus 3 over 3 minus x. Now x minus 3 and 3 minus x will cancel out, leaving minus 2 for us. So we get f of x equals to minus 2. So basically it is a function which is a horizontal line, correct? So this is kind of a horizontal line, kind of I can draw here and show you the function with a discontinuity at 3, right? It's a horizontal line, but it is discontinuous at 3, right? Well, this horizontal line should have been at minus 2, so let me draw it here. So it's a horizontal line, f of x equals to minus 2. So that is minus 2, and that's the horizontal line, and it does have a discontinuity. The type of discontinuity is a hole, because that cancels out with minus 1. Do you see that? And so minus 1 times 2 gives me minus 2. And the discontinuity is at x equals to 3. So if this is the value of x equals to 3, then on this line I have a hole here, and rest is kind of like that. Do you see that? So that is your function right here, correct? So the discontinuity here is a hole at x equals to 3. So that is the answer, correct? Now B. Identify discontinuity in the graph of f of x equals to x plus 1 divided by x squared minus 1. Now in such graph you should factor the denominator, right? Correct? So if you factor the denominator, you get x plus 1 divided by x plus 1 times x minus 1. Now x plus 1 and x plus 1 will cancel out, giving a hole at minus 1, and vertical asymptote at 1. So we got two types of discontinuities here. So we have a hole at x equals to minus 1, and we have a vertical asymptote at x equals to 1. So let's now see the answers. So vertical asymptote without a hole, vertical asymptote without hole, it will not work. Vertical asymptote at x equals to 1, and none of them. So the choice is none of them, because they haven't really mentioned about the hole at all. And they have written vertical asymptote at x equals to plus minus 1. Well, this is not a vertical asymptote. Since we have a common factor in numerator and denominator, we have a hole at x equals to minus 1, not a vertical asymptote, correct? So the choice is none of them. Thank you.